Sitting comfortably? Then we'll begin. Good evening, ladies and gentlemen. I'm sure you're all dying to know what's been going on in the kernel. I'd love to know, because I'd love to know what he's doing in there, when I'd rather have him for other purposes. So it is my distinct privilege, and by privilege I mean I bagsied it when the sign-up sheets were going around, to introduce to you the most brilliant and beautiful kernel hacker, I'm sure you'll all agree, Ben Hutchings, telling us what's new in the Linux kernel. Here.
I'm hoping that my slides will appear on the...
Microphone.
No, that doesn't look like my slide. I had more words on that than that. Yes, that looks like it. Okay, so I gave a somewhat similar talk last year about what was new in the Linux kernel, and this year some different new things have happened, so this talk will not be exactly the same, although it's a pretty similar shape. To just gloss over who I am, I'm a software developer or software engineer, depending on what my employer chooses to call me this year, by day, and Debian developer at night, although since I've started working at home, sometimes timing's the other way around. I've been working on the Linux kernel since about 2008, both in Debian and in my paid work. I'm currently doing most of the maintenance for uploads to Unstable, aside from all the non-x86 ports, which I don't really know very much about. And I'm also maintaining the stable updates to Linux 3.2 at kernel.org, which then those then feed into Debian and various other distributions that are based on 3.2. As has been advised for free software projects, Linux releases early and often. Currently about 5 times a year. There's no release schedule, but it works out as about that. Then there are stable updates every week or two, which are just supposed to fix bugs and performance regressions. Some of the new features that appear in a stable release aren't completely ready. Some of them need support from userland. In the last year, there have been 6 releases, 3.11 to 3.16. So we have lots of new features, some of which need integration, some of which we just need to turn on in the kernel package. I'll recap what happened to the features that I talked about last year. The team device driver needed a userland support package called libteam, and that was uploaded in October. The team device is supposed to be a better replacement for the network bonding device. Transcendent memory. I did think we needed to have a bit of a think about what to turn on, whether we needed to do some scripting perhaps for that. None of which has really happened, but when I was preparing this talk, I looked at the options that were there. Partly, the transcendent memory framework was present, but a lot of the specific plugins for that were not. So transcendent memory is about having a layer in between the working memory, which can be mapped into processors, and the swap file or swap partition and files on disk. Because the disks tend to be a bit slow, it's maybe useful to have an intermediate layer between those. So we now have Z-swap, which lets you, instead of writing pages out to the swap partition, instead compress them, keep them in memory, and that sort of serves the purpose of reducing the amount of used memory, while also it's much faster to decompress those not quite swapped out pages than to bring them in from the disk. Zen also supports this sort of intermediate state with the aid of the hypervisor. So that will be enabled in the next kernel upload, Linux 3.16 point whatever it's going to be, going into unstable soon. The new KMS drivers that I talked about, as far as I know, those are now supported by the Zorg drivers in testing. Module signing hasn't been enabled, but that's mostly because we haven't really made progress with secure boot. So at the same point that we get kernel signing for secure boot, we should also have module signing, and that should give you a lot more assurance that the kernel you're running is the kernel you're meant to run. It also talks about having more support for discard, which is a way of improving the efficiency of SSDs. If you tell the SSD that some blocks are not currently in use, it can do a better job of wear leveling, and your disk should be a bit faster and last longer. Unfortunately, we're still not enabling discard for SSDs automatically when you install Debian. You have to know what options to turn on later. There's an open bug for that if you want to work on it. Last year I talked about improvements to containers. We finally had user namespaces implemented properly, so you can create a container where the user IDs are can start with 0 for root, and still be completely distinct from the user IDs that are numerically the same on the outside of that container. And you can also have the special capabilities that normally associated with root. You can give those to the containerized root, and it will be able to have powers over the processes in that container, but not outside the container. One of the blockers for that was XFS, because every file system needs to be able to distinguish the user IDs in the current user namespace from the global user IDs which get written out to disk. Glad to say that has been fixed, so we've been able to enable user namespaces. And I believe LXC and possibly some other container systems are now using that. Bcache, I believe people are using that. I think someone talked about it on Planet Debian, though I don't remember who. However, the Bcache tools package that's needed to configure that is not packaged. There's an open bug for an open ITP bug. I think there's some kind of licensing mix-up there that needs to be resolved. But if you're interested in Bcache, please go and look at that bug, see if you can help resolve it for Jesse. So ARM multi-platform. I believe we now have Debian installer working for some of the ARM v7 boxes with the multi-platform kernel. Don't know if anyone can give a specific. Anyone know? Anyone got DI working on v7? Well, I think it works. Maybe. There's some progress on GPU drivers, I believe, because NVIDIA, somewhat surprisingly, has helped with to get Nouveau supporting their Tegra SoCs, which have somewhat similar GPUs to their PCI Express cards. So Nouveau is suitable for both. And then the Novena project is sponsoring development of the Etnaviv driver for the GPU that's used on their laptop/development board. Quite when that will be ready, I don't know. So getting on to the new features that have appeared in the last year. Unnamed temporary files. Not very exciting, but kind of useful. Currently, if you can create a file that is not linked into the file system using the C library temp file function, but actually that does have to create a file with a specific name, which it will try to generate a random name in usually /jump, and if that fails, it'll try another name and another name and another name until finally it comes up with something that no one's using, and then it will immediately remove that file, which didn't really need to have a name. So there's now a kernel feature. There's the option otemp file, and if you specify that, and you specify the name of just a directory, then you'll get a new file which is in the same file system as that directory. Sorry, assuming you have permission to create a file in that directory, you get a file on the same file system that doesn't have a name, never had a name. And one of the interesting things you can do with that, which so far as I know you can't do with if you use temp file, is you can actually give this nameless file a name later using the link at call. So the result of that is you can put content into your file, you can set all its metadata like permissions and ACLs, whatever extra attributes you want, and link it into the file system, and it's as if the file had been atomically created. There's no other process is going to see this file in an incomplete state. So that's probably kind of useful for some applications. I'm not exactly sure what, but think what you can do with that. Unfortunately, it's not supported on all file system types. It needs specific support in each file system. So you're going to need a fallback unless your application can depend on using specific file system types. And of course, it was only added in 3.11, so if you need to support other kernel versions, you still need a fallback. I'm going to skip over this and come back to it if I have time at the end. The Lustre file system is apparently quite popular in cluster computing applications. It's a distributed file system, which is a bit different from things like NFS. It doesn't have a central server. It's been around for a long time, since 1999. So why am I talking about this as a new feature? Well, now it's in the Linux staging directory, and it's being updated for each new version of Linux. So at the very least, it does build against current versions of Linux. Previously, it was kind of lagging behind the kernel, and although we had Lustre in Squeeze, it wasn't released in Wheezy because it didn't work with Linux 3.2. And unfortunately, it's dropped out of Debian completely now. So while we have the kernel side of it working again, we are missing the userland side. So I dropped a mail to the former Lustre maintainers. Maybe they'll add it back in. If you're maybe they need help. So if you're interested in getting Lustre back into Debian, that's something to look at. Btrfs has gained support for deduplicating files, which you can kind of do in a way by using hard links, but the problem with hard links is then an update. You might not want updates through one path to affect the other path. You want to share storage, but maybe have a copy on write behavior. Now, Btrfs generally doesn't update data in place. Instead, it makes a new copy, and it drops a reference to the old data. So you can have data shared between files without necessarily linking them. Snapshots are very cheap, and you can also do a kind of a cheap file copy. Currently, that requires an IOCTL, although possibly CP has a special option for it. I don't remember now, but you need to ask for it specifically. So you may well end up with multiple copies of files anyway, and you want to save space by deduplicating those. Btrfs isn't going to do that for you automatically. It's not going to actually go out there and scan. It leaves that to userland. So you still need a dedupe tool, and you need one that's going to you probably want one that is going to enable copy on write rather than linking. There is one of these tools called bdup, but it's not in Debian yet. So any Btrfs fans out there want to have deduplication, think about packaging that.
I think I have a bug report to do that. Requesting for me to do it. Yeah.
Is that going to be part of an existing package?
Part of Btrfs tools, yeah.
Apparently it's going to be part of Btrfs.
Stream, but I'll just package it together.
Okay, so it looks like this is going to be added to Btrfs tools. NFtables, it's yet another firewalling API. As if we didn't have enough already. Okay, well I'll explain why this is actually a good thing. Currently we have IP tables for IPv4, we have IP6 tables for IPv6 firewalling, we have ARP tables for the ARP protocol, and we have EB tables for Ethernet bridges, working at the Ethernet level. All of them are protocol specific. They need a kernel module for each kind of matching you might want to do. They need a kernel module for each action. I think some of the actions are somewhat shareable between these. They're all based on the kernel's net filter API internally, which is somewhat more flexible, but only if you're prepared to write another module. So the NFtables API exposes more of that flexibility. It adds a kind of virtual machine similar to the Berkeley packet filter that's commonly used for packet filtering on sockets. I'm not quite clear on why it needed a different virtual machine, but apparently it did. BPF wasn't quite good enough. So userland can generate matching code and upload that into the kernel, and it'll all be safe probably because it's limited to what it's sandboxed within this specific virtual machine. So we have a userland tool, NFtables, which uses this API. It's already packaged, so that's great. But the next stage, which is going to happen somewhere down the line, I don't know quite how far off it is all those old firewall APIs are now redundant. But because you can generate all that matching code in userland now, you don't need specific native code for it. So the userland tools, IP tables, IP6 tables, and so on, will need to be ported to use NFtables. Hopefully upstream maintainers for those will do that. All right, so lock debugging is something multi-threaded programs often have bugs involving locks, and the kernel is a massively multi-threaded program. It has every single task that exists in userland can also run in the kernel, so you've got a thread for each of those. You have kernel internal threads, you have interrupts, you have soft interrupts, you have non-maskable interrupts. So you have a huge number of interesting interactions there. Lots of different synchronization mechanisms, mutexes, spin locks, RW locks, and you have locking operations that may inhibit interrupts or soft interrupts temporarily. And hopefully we avoid data races that way. But with all this locking going on, unfortunately we might do locking in the wrong order and get deadlocks. Easy to introduce, and of course they will bite users in the field, and then we don't know how to reproduce them. For some years now, the kernel has had a system called lockdep, which dynamically tracks the locking operations, sequences of locking operations. But then it will do a sort of a static comparison of these dynamic sequences, and it will work out, supposing these sequences occurred in parallel, then could that potentially result in a deadlock? And so, although it's not a pure static analyzer, it can very quickly find many types of deadlock bug. So that's helped to find and fix a lot of bugs, and in conjunction with the Trinity fuzzing tool, that's resulted in a lot of improvements in the robustness of the kernel. So now you too in userland can use lockdep just as soon as we get around to packaging it. It's available as a library, which is in the Linux source tree, and it should be built from the Linux tools source package, only it isn't yet. So I hope to find time to do this. If that's something that sounds really interesting to you, then please help. So we have a couple of new ports. Well, actually, there are lots and lots of new architectures being added to Linux all the time, many of which are not supported in Debian. But the ARM64 architecture, although it sounds a lot like ARM and comes from the same company, is actually very, very different from the 32-bit ARM, and it's currently treated as a completely separate thing in the kernel. The initial support for this was added over a year ago, but it wasn't really usable. But in the last year, it has become usable. It's in fact, it's reached a point where you can run it on both emulators and real hardware. I believe that the Debian packages of the ARM64 kernel do run on real hardware, although I haven't seen it happen for myself. If anyone wants to donate me an ARM64 board to test that, I'm perfectly willing to take it. The kernel's had support for PowerPC for a very long time, we've supported several different variants of that. We've had PowerPC 32-bit in Debian. We've had an unofficial port to 64-bit, both of which are big endian. And the kernel has always run as big endian, although it supports little endian userland. I don't think we support that in Debian, but the kernel did. Recently, there's been the Open Power Consortium has decided that Power is going to be far more popular if only it was little endian. I think that's what it is anyway. So we now have the PPC 64 EL port, 64-bit, little endian, both kernel and userland. That landed in Linux 3.13. The kernel can run as little endian as well, and there's a subtly different userland API for that. And both of these are being bootstrapped in Unstable as we speak. I think they're making quite good progress. They might even make it into Jessie. So file private locking is another one of those things which is not particularly exciting, but it sort of fixes a bug in POSIX, which is POSIX is the standard that Linux and Unix and similar kernels attempt to follow as a kind of a core interface to a core API. POSIX says that if you lock a file, then as soon as you close any file descriptor to that file, your process drops its locks on that file. Thing is, you can open the same file multiple times. You can have multiple file descriptors. If you have a multi-threaded process, you might well have multiple threads that don't know about each other, opening the same file, locking the file, locking different ranges of the file, because these are ranged locks, not whole file locks. As soon as one thread closes the file, oops, it dropped the locks that belong to the other thread as well. So your multi-threaded process now will need serialization around opening and closing files, which is a bit silly. What's more, you have the problem of hardened symbolic links, which mean that maybe those files you thought were two different files are actually the same file. So this serialization still doesn't help you. So we have a solution to this. We have a new type of lock, which, well, it's almost the same type of lock, but it has the right semantics. Now it's associated with the open file handle. So the two threads that open the file now have completely separate sets of logs associated with their open file. Multi-key block devices don't need anything new from your application. These are a performance feature. Every block device that corresponds to a physical device, a physical disk, is likely to have some kind of command queue or request queue, which has all the reads and writes that have been started or are about to start on that block device. Depending on the capabilities of the hardware you might only be able to send one command to the hardware at once, or you might be able to send multiple commands. That's called NCQ. In any case, the queue is maintained in software. If you only have a single queue for your single device, then adding things into the queue and taking things off, handing things over to the hardware, that has to be serialized. And then the completions are also being handled through a single context. So you potentially have interprocessor interrupts to wake up processors on other CPUs. So if you have a really fast SSD, that can be a bottleneck. If you have a really fast SSD, it might actually support multiple queues. But that doesn't help you so long as the kernel is using a single queue. That's finally changed in 3.16. You can have, if the driver supports it, there can be multiple queues for a block device. You can have multiple CPUs adding to these queues in parallel, sending commands to the device in parallel, and completions come back in parallel, and hopefully everything gets. You don't have any. You don't have so much contention between different tasks using the device. So far, however, there's only one driver that supports this, which is MTIP32XX, which is for a very expensive family of SSDs. I believe that the SCSI block drivers for the SCSI drivers that work with some other kinds of SSDs are going to support this soon, but they missed 3.16.
NVMe?
Oh, I missed that. Okay, so NVMe.
Could you repeat that with the microphone, please?
I'm repeating it with the microphone. So NVMe is already multi-queue. Okay, great. So I think that covers all the really fast SSDs.
Yeah.
Probably.
Yeah.
Great. So
Oh yeah, 10 minutes.
okay. So if anyone has questions, I can ask them now. I can also go back to talking about the network busy polling, which is another sort of interesting high-performance feature.
There's a headset right in front of you.
There is,
I
yeah.
tried to tell him, but
You didn't try very hard.
I totally tried. Can I just have another mic, please?
Look, I've only got those two.
Give him the wired one and ask for wireless.
Is this working?
There's no wired one.
Can you hear him?
Probably need to turn it on. Yep. Okay.
Okay. Questions?
Now we're going to find there are no more questions.
Now I want to run around. Come on, questions, asking things. He totally answers.
So with just
Into the mic,
thank
please.
you. With Jesse having frozen at 316, but it's not yet like slushy, I heard is the description. What is the
Well, it's not. We haven't frozen. We're not freezing until November.
okay?
And well, 3.16 isn't in unstable yet. The next upload will be based on 3.16.
So what is the opportunity for getting patches that were accepted and queued for 317 into 316, Jesse?
The chances of that happening are very good if you ask now. Less so as we get towards the freeze, and beyond the freeze, we can still take patches for hardware enablements, so new drivers, support for new models, and so on. They're still okay, but the earlier you ask, the better.
I don't believe personally that GRSec is magic, but so many people have been requesting that GRSec get in Debian that it's getting on my nerve. Is there a chance that we ever get maybe a flavor GRSec in Debian?
GRSec is not going to support 3.16 for very long, so far as I know. So that's not really going to work as a patch within the Linux package. There was some discussion several months back about the possibility of doing a separate Linux GRSec package, which will be based on the 3.13 or 3.14 branch, whichever it is that's going to have long-term support from the GRSec developers. But I haven't seen any sign that that's actually happening. I don't think anyone's tried uploading to new yet. It's not going to come from the kernel team because we've kind of got our hands full.
If you ask questions, wave quite hard. I can't see you otherwise.
Hi, thanks for all your work on the kernel team. First, maybe just to make sure I understood the answer to the previous question, I think your answer was if someone wants to upload Linux GRSec, then that's plausible. Is that basically the summary?
Yes. I mean, the usual objection to that would be it's more or less duplicating code, and the security team doesn't like there being duplicate code in the archive. However, in this case, I think there was a tentative. Yes, it would be okay in this case because both of them are fairly well supported, or something like that.
Okay, and then my other question is about backports kernels. I use backports kernels, but I kind of just install them willy-nilly whenever. Is there a schedule or a plan, or I'm glad they happen, but when and why do they happen?
They are, I hope, kept more or less up to date with testing. I don't always remember to upload as soon as the testing propagation happens, but I hope I'm doing the uploads in a fairly timely fashion.
Thanks.
Next, please. Any further questions?
Sorry, that goes for Wheezy backports. I haven't done any uploads for Squeeze backports for some time now, and possibly I may do that to support Squeeze LTS, but I haven't got around to it yet.
Sorry if this is a question from an outsider, but from an outsider view, is there any qualification process or testing done on the kernels as they go into either backports or testing or unstable? With
No, not really.
Okay.
For testing propagation, it's the usual rule, which is if there are new release critical bugs raised against the version in an unstable, that will block propagation to testing. And hopefully, if it's okay in testing, well, anything that goes into backports was previously in testing. So, barring compiler bugs or incompatibilities, then it should be all right in backports as well. It's not really very satisfactory, but that's without a hardware qualification lab, that's the best we can do at the moment.
I was asking this in particular because a lot of Google Compute Engine's customers are running the backports kernel. In fact, the vast majority are.
Right.
And around the upgrade from 3.14.
Yeah,
Sorry. A lot of the customers were. Oh, sorry. Sorry. A lot of the customers. So a lot of Google Compute Engine's customers, the vast majority, are running the backports kernel.
Okay.
Around the upgrade from 3.13 to 3.14, customers would get the kernel as it comes out, but we had a very large number of bugs start appearing. So I was wondering if there was any plans for a testing process or a qualification process around kernels being put into backports.
If you want to help with that, if you want to provide some of your engineering time to help with that, that would be very much appreciated, because no one wants to upload broken packages, but as it is, no one on the kernel team has a lot of time to spend on this, unfortunately.
Anyone else? Looks like that's everybody. Right. Looks like we're done here. So thank you all very much for coming out in droves to hear about the kernel.